let's take a look at an entity in our veterinary appointment scheduling application, Front Desk. We're going to look at the appointment class, which defines all the information that we need to schedule an appointment for a particular animal or patient. It associates the patient with the doctor, room, and appointment type, and also includes the start and end time for the appointment. Now, the appointment class inherits from base entity of T, which is a generic base class. In this case, it's base entity of GUID, as you can see here. The GUID is defining the type of our identity property, our ID.
Right, and we talked about that earlier when we were looking at the structure of the different entities in this model. We wanted appointment to have a GUID because we're creating new appointments on the fly. So let's take a look at that base entity class. First of all, it's an abstract class, so we can't just create a base entity object. We have to create something that is a base entity, such as an appointment. And using generics, we're saying that the base entity is going to use whatever type we ask it to, and that type is for defining the ID. So for appointment, we said base entity is going to be using a GUID as its identity. I mentioned this earlier, why I would need GUID for appointment in this context, because I need to be able to create new appointments in this context, and I'm not going to be waiting for the database to generate that ID for me. So using a GUID lets me create that ID right up front as I'm creating that new appointment, so I'm giving it its ID. The base entity class also has a property to hold a list of domain events that will define explicitly for each of the types that inherit from this base entity. You'll learn more about domain events further on in this course.
All right, so let's take a look back at the rest of appointment. Now, since appointment has more behavior than just state, we don't want to have it just be a bag of properties that our application can get and set however they would like.
Because that would be an anemic domain model.
Yes, because that would tend to lead us toward a more anemic domain model.
And we want a rich one.
Now, in particular, we're also constraining how we create this appointment. We want to ensure we create appointments in a valid state, so that means passing in the minimum necessary elements an appointment needs to have. Sometimes we'll want to update an appointment. Remember, these aren't value objects. They're not immutable, so we can change them. When we need to modify an appointment, we're going to do that through methods. And so, for instance, if we decide we want to modify what room an appointment is scheduled in, we're going to do that through a method rather than just a setter. We do this because there's additional behavior we may want to do. In this case, we have some guards, again to ensure a valid value is being passed.
These guards are a set of reusable functions that you'll find in the shared kernel of our solution.
And we also want to raise an appointment updated event that we might handle and send a notification or perform some other action as a result of what happened.
And that also gives us the flexibility in the future to change what type of logic we want to trigger.
And that's something we can't do very easily if we've just let anybody in the application set the value.
Right.
By providing a method to use to update room explicitly and otherwise making the setter private, we force all interaction with the model to use this method, which gives us just one place to model behavior that should be associated with this operation. It's the same as with the constructor. We need to do our best to keep our domain model in a consistent state so the rest of the application can count on it being correct.
Right, because otherwise somebody could satisfy the requirement that they pass in the room ID, but they might pass it in as 0, which would be invalid. So we're further constraining that they don't do that either. The appointment would be invalid if it had a room ID that didn't correspond to an actual room entity. And in any case, the database wouldn't let that fly since there's a foreign key relationship between appointment and room.
Yes, but we want to make at least some effort to catch such problems in our code, rather than relying on the persistence store to inform us of a user error. Overall, using guard clauses, like the ones you've seen here, help us ensure our entities aren't partially constructed and inconsistent. Once we've created an appointment, we need to record it as part of the clinic schedule, which involves some additional rich behavior. So if we scroll down to the bottom, we have this method called schedule, and this is where we're going to do the additional work involved with actually saving an appointment and ensuring it fits in with other appointments that have already been scheduled. We're not going to worry about the code at the moment, but the idea is that this method would query the database for other appointments that might be near this one and make sure there is an available slot in the schedule that this one fits into. Then it will save the appointment and raise an event letting the rest of the app know that a new appointment has been scheduled. In the next module, we'll investigate this design further and revise it a little bit. Now, let's look at one more simple entity that this bounded context needs, the doctor class. You can see that doctor inherits from base entity as well, but in this case, it's using an int for its key. The only other property it has is a string name property.
This is a minimal implementation of the doctor type that satisfies the scheduling bounded context. It's essentially no more than a reference type. Doctor and the other similar types, patient, room, etc., are all organized into this folder called synced aggregates. Let's dig a little more into how these reference types in the scheduling bounded context are getting their data from the clinic management app, especially if the two BCs aren't sharing a database. If you recall from seeing the class descriptions of all of these classes, the appointment type, client, doctor, patient, and room, we had explicitly decided that these are reference entities where we're actually doing their maintenance elsewhere, so they're not adding any unneeded complexity to the front desk application.
Right, and they're just read-only, so we're never having to create or modify them.
And we're using the ints that were created by the database when we persisted these with a CRUD context in a different application. But they're still entities here, just entities of type integer. The clinic management bounded context is responsible for updating these types. When changes are made, application events are published by clinic management, and this front desk bounded context subscribes to those events and updates its copies of the entities.
One of the questions we get all the time when we describe how bounded contexts have separate databases is, how do we synchronize changes between these two apps? This is one of the simplest and most common approaches. One app is responsible for updates, and the other apps just subscribe to the changes and are notified when they occur.
This is an example of eventual consistency. The two systems aren't immediately kept in sync using a transaction or something similar, but through message queues, eventually the different bounded contexts are updated to the new state when a change is made. We've covered a lot of ground in this module, and you've learned a lot of new terms, so we just want to review some of them with you before we move on to the next module. The first is a pair of terms that often go hand in hand, anemic domain models versus rich domain models. And remember, the anemic domain models, while often looked down upon from the perspective of DDD, they're perfectly fine for CRUD. These are models that look a lot more like a database schema than a class that has lots of methods and rich behavior in it. On the other side of that is a rich domain model, which is what we strive for in domain-driven design, and that's a model that really is focused on behavior, not just changing the values of properties.
Then we talked about entities, and entities tend to be one of the core pieces of our domain model. The key thing that distinguishes an entity from other types in our model is that it has some kind of identity that we can use to track it over time and to bring it in and out of persistence.
This module provided you with your first look at implementing a bounded context in code, an important part of tactical design. You learned about the difference between anemic models and rich models, and that while anemic models have their place, focusing on behavior with rich domain models is how DDD lets us solve complex problems. Entities are the classes in our domain models that are tracked by an identifier, allowing us to build graphs and eventually persist and retrieve that data. Sometimes we are working with entities whose behavior and rules are critical to the bounded context in which we're working. Other entities may only provide supporting or reference data. You learned how to help identify the differences between them. Then you got to look at the appointment class in our scheduling app to see how we have applied rules and behaviors in that entity. You also looked at one of the reference entities and learned how we use message queues to ensure the reference entity data that is maintained in the clinic management app is made available to the scheduling bounded context
even though they do not share a database.
In the next module, we'll focus on some more important elements of a domain model: value objects and domain services. We've referenced a lot of interesting and helpful resources in this module, and here are 2 pages of links for you to follow up with if you want to dig in a little further, including Steve's Pluralsight course on solid principles of object-oriented design and information on event storming and event modeling. This is Julie Lerman.
And this is Steve Smith. And thanks for watching our course, Domain-Driven Design Fundamentals.